Yes, good afternoon. I think you can, the voice is audible to you. Is the voice audible? Yeah, fine.
Yes, sir.
Yes, sir.
Okay, fine now. Now, today, uh, we start with this one. And once I finish this uh, topic, I'll be able to give you some problems based on this. Now, priority queue is one of the variants of queue. The other one which we have to do is double-ended queue, the DQ, called as double-ended queue. Now, these are all queues only, but they are variations of queues. Now, in that case, a queue could be a normal queue, it could be a, a circular queue or a priority queue or double-ended queue. These are all types of queues, but it's the same data structure where you are only going to perform deletion or insertion based on the concept. For example, in a priority queue, you are going to remove the elements based on priority. Or you can say you are going to process the elements based on priority. A double-ended queue, the name is very clear. Double-ended means two-ended. That means a queue which could be like this, where you can insert or delete from both ends. Now, a queue which can be like this, you can think of a queue where both the ends can be used. Or it could be a queue where you can do insertion from both ends but deletion only from one end. That means you can insert from here also or from here also, but delete can only be done from one side. Or the other one could be like this, where you can delete from this side, but insert only from one side. Insert can only be done from here, delete you can do from here, delete you can do from here. Now this one is called input output restricted queue. It's called as output restricted queue because you can only do output from one side. This is called as input restricted queue. Now we'll discuss this also, but what I wanted to say you is that when I talk about these data structures, these are all queues only. Therefore, don't confuse that these are different data structures. These are all same. That means they are all variations of queues, or you can say subset of queues. But the whole thing is that elements are inserted or deleted based on the same principle of a queue. Now, what we are going to do today, we are going to do a priority queue first because priority queue is an important one, and therefore this has a lot of applications in computer science. Maybe in the case of this computers, DQ is not very much used, but priority queue is very much used, and therefore we are going to do it in a details. Therefore, we are first of all let's start with a priority queue. What's a priority queue? And therefore, now here, as the name says, priority queue is a queue which has following properties. It has the properties. That means every item or every element has a priority associated with it. That means whenever you want to insert an element, you have to have a priority for this. Second property is this: an element of higher priority will be processed first. Processed means it is going to be dequeued. Processed means it has to be removed because insertion you can only do as and when the elements are coming. But here processing means I could write over there that it is, you say it is removed, you are deleted first. Or the better word what we are using is called dequeued. That means removing from this. Therefore, I could have used better word over here, dequeued. Dequeued means it is going to be removed over there. Okay. DEQUEUED. That means removing from the queue. That means, see, insertion there is no priority. The elements are coming, you are going to insert. But if you are going to remove only, then only that DQ is there. Therefore, when I say processed means removing. When I say deleted means removing, dequeued means removing. Therefore, I am just using different word. And the third property is this. If there are elements of same priority, they are processed as per the order. If two or more elements are having same priority, they are processed. Process means again dequeued as per their positions. As per their positions. As per their positions. That means as per the order in the queue. Now again I tell you, process is nothing but same dequeued. Okay. Now here, based on this particular one, what I will be saying is that I will write it a little over here, are dequeued okay. If two or more elements are having same priority, then they are processed as per their position. That means as per the positions in the queue. Okay. Now here, let me try to make you understand that what is the meaning of this. The meaning is that now where is the actual scenario where you are going to work. Now let us try to work on to show where is the actual use of this. Now suppose you are having a one server and there are a lot of PCs which are connected to this server. Now there are a lot of PC which are connected to one server like this. Now, what happens in normal scenario, and you know that very well. Suppose all these PCs, everybody is using these machines and giving some particular command for the server to perform. It is very, very common. What you find over there is that you are going to find in a railway system where a clerk is there and people are queuing in different counters and trying to book a ticket. Okay. Now suppose everybody from say hundreds of terminals is trying to book a ticket. Now what happens? The clerk is going to enter the things, and once suppose two or more people are trying for the same berth in the same train, obviously the person who is giving the command first will be booked first. Now it means that at this server there will be one queue which will be maintained. It will maintain a queue over here. The queue will be maintained over here at the server, and as and when the request is going to come, this will be coming in the PC. Okay. Now in this case, you might request come from PC number 4. Here it might come from PC number 2. It might come say from PC number 25, and so on. Now what happens is that if everything is in the queue, it is going to do in a first come first serve basis. But sometimes you might find that my job has to be done before that because of some urgent things. Now suppose my job let us take example that my job is given from PC number say 10, and I want my job to be executed first. Obviously, when this is being done like this, you cannot do, because before this one, before this 10, 4, 2 and 25 will be done, because you are maintaining a queue. But I don't want. I want that this should work with a priority. That means I want to execute first the job from PC number 10, then PC number 4, and then PC number 2, and then PC number 25. That means I want to put this over here. But I can't do, because a queue will always be it's a linear, and you cannot try to put something in front. How to solve the problem? Obviously, in a normal queue or in a circular queue, you cannot do this. But in a priority queue, you can do this. Now, what will happen? I will set a lower priority to the job which is coming from 4, 2, and 25, whereas I am going to put a higher priority to the job coming from PC number 10. Now, what will happen? Once the elements are dequeued from here, when the elements are dequeued, or you say it is deleted from here, it will be deleted based on the priority, not by the positions. Okay. Now, if you are going to do like this, obviously this order will be maintained. Now, this order will be maintained because the priority number for this one, this may be 1, this may be 2, this may be 2, this may be 2. And a higher priority is indicated by a lower value. That means 1 is always having a higher priority than 2. 2 is having a higher priority than 3. And this is a common scenario which is. Now let us try to do in a very, very different scenario. Suppose you are working on the same server. And what happens is that what you are trying to do is that you are going to execute programs from your PCs on the server. And suppose by mistake you written a program, and that program is going to hang the server. Or maybe the server resources are used by you. For example, you are using a CPU, or you are using a lot of memory. Now I am being a system administrator, and I want to make sure that everyone gets a fair chance of everything. Now suppose here I am the admin sitting over here. What I will do is that I will just try to remove your job from the queue. Suppose you are given from here, suppose this is PC number 2, you have given this one, and what I will do as an admin, I will delete this job. Delete means I will remove you. Remove means DQ you, or I will remove you. Now in that case, how will I remove in between? Because already I have a PC4 before that. What I will do is that I will raise your priority to the highest level. Once I will remove you to the highest level, the system will automatically remove you from the queue. And this is a common scenario where you are using this type of problems. You are not going to do in normal conditions. You are only using in the situations where this will happen. Now, most of you have not worked on the systems, but if you see around say 10 to 15 years back, there was a system called Unix system were there. Unix system had a typical concept that it will work like a client server technology. It will work as a client server technology, client server architecture. The client server architecture is nothing where you are going to use like this. You are having a server, and these are all terminals, or we call it workstations. We call it workstations. Anybody can tell me what is the difference between a workstation and a PC? What is the difference between a workstation and a PC? Or you say a terminal and a PC? Anybody has an idea? What is the difference between these two?
सर सर्वर में मेन कंप्यूटेशनल होता था और टर्मिनल में मतलब सिर्फ कमांड भेजे जाते थे, मतलब
हाँ,
मेन सेटअप जो सीपीयू
उसमें क्या
प्रोसेसिंग
नहीं
यूनिट वो
होता?
सर्वर में था।
दैट मीन्स उसमें क्या नहीं होता है?
सर वो सीपीयू जो मेन प्रोसेस करता है वो सर्वर में होता था, और
तो ऐसा
बाकी
क्यों
सबको
होता है?
कीबोर्ड और स्क्रीन में देते थे टर्मिनल से इंटरैक्ट करने के लिए।
ठीक है, what you're trying is correct. Let me make it clear, more clear. Workstation do not have a CPU. They even do not have a RAM. They even do not have a hard disk. These only contain your piece, your keyboard, a mouse, a screen, and one we call it terminal emulators, which is going to connect your machine to the server, and all the CPU, the RAM, the hard disk will all be at the server. And your machine is also, sometimes people call it a dumb terminal. They also use a word called as dumb terminals. Dumb terminals means they do not have a processing powers. And these are basically workstations. Now, what happened around 10 to 15 years back, the PC was very costly. Therefore, people used to buy one server, and these dumb terminals were cheap enough, and then people used to buy around 20, 30, 50 machines which are dumb terminals and working on a server. Even we have, if you will come to our department, I show you, we are already having a Solaris system. We are already having a machine, Sun Solaris machines. We are not using right now. We are using around 3, 4 years back. These are basically based on totally client-server architecture, where I have a very good server, and the terminals are nothing but monitors and keyboards. That's all. And there is a wire which goes from, like this, a wire which goes from workstation to the server. Now, this is just because of two factors. One, I want to save on the amount of investment on the PC. And second, I want to perform every task on a single thing. Now, if you will go sometimes to book a ticket on your railway reservation system, you will find that this system is already there. The clerk over there who is sitting will be having one terminal which will have a screen, monitor, one keyboard, one mouse, a printer, and one small thin terminal emulator, something like this, a thin which contains a wire which will go to the server. Now, this is necessity. Why? Because you want to book tickets from a central database, and therefore this is very, now this is called, it's called a terminal emulators. It has a very small amount of RAM just to display what you are typing. That's all. Whatever you type from the keyboard, it is displayed on your monitor with a small amount of RAM. But for the processing, it will use the center server. That means we use the center server. And this architecture is even very popular, except that now people, what they are doing is that they are replacing the workstation with a PC, because cost of PC is now gone down drastically. Therefore, it's useless to buy a workstation. They will buy a PC in around 15,000 or 12,000, because you don't require a very high-end CPU with that. You require a simple CPU, but you do not use the CPU. The CPU will be used by a server. Now, this type of architecture is very. Now, in this one, you require a priority queue, because if somebody is going to hang your server, I will, as administrator, will try to remove that from the things. And if you are going to use this concept, now let us try to see how it actually works. Now, suppose I am using a priority queue like this. And I have given a command, I say insert, say A. Then I say insert, suppose B. Then I say insert, suppose D. Then I say delete. Then I will say insert, say B. Okay. Now, if I say insert, what is the queue will be something like this, or I will say delete. I will not say like this. I will say delete min. Now suppose I say A, then I insert P. What happens? A will come here and P will come here. We assume that Q is like this. Any problem, please ask. Because if you go by the books, the Chomsky do not have these concepts. They are given in half pages, but I am trying to explain you from being a computer engineering student who is going to learn those computer engineering subjects. Now, when I say delete, insert D, what happens? A will come here, B will come here, and D will come here. Now, suppose I say delete min. Now, from this minimum is A, because A is having the lowest ASCII value. Therefore, what will happen? You will remove P and D, and now this is the content of the stack, sorry, queue. That means you have removed A. Then I say insert B, D, and D. And I again say delete min. Now what happens? It will not remove P, but will remove D. Then what will happen? The content will be P and D. And this is the main concept which I was talking about. It is going to remove this one. It will remove P and not D. Actually, if in normal queue, it should have deleted the one which is come first, because P has come before D. But in a priority queue, it will remove the one which is having the lower priority. And in this case, I am talking about the priority as a alphabet which is having a lower value than the bigger one. Now in that case, A is having the 1, that means the A comes before B, B comes before C, and so on. We can remove this. Therefore, this is a priority of things. Now, if I am going to implement such a things in a queue, it is called a priority queue. Now let us try to understand that how it is going to work over there. Now, what you are going to do, if you are going to do like this, you have to assign a priority to thing. Therefore, when I am going to put an element, I will declare like this. I will have an element, comma, priority. That each element will be given by the element value and the priority number. For example, I might have written, say, example, I might have an element A with a priority 4. I might have an element B with a priority 3. I might have element C with a priority 4. I might have element D with a priority, say, 2. And E with a priority, say, 3. Now, while inserting, obviously we will insert like this. You will insert like this: A, 4, B, 3, C, 4, D, 2, and E, 3. Okay. Now, if I assume that the lower number is a higher priority, then which element is the most priority? Is obviously D, because in this case you are having an element which is having a priority. Therefore, in this case, this is having the highest priority. Because of the value of this to be the minimum. Now, what I am going to do is that I am going to delete the elements. I am going to delete the elements. Now, obviously delete, you have to do the, now after deletion what will happen? When you delete, what you're going to, when you delete one time, when I delete, the queue will become like this. A 4, B 3, C 4, and D 3. And you find that D is now removed. So here what you find over here is that you have removed D. You have removed D. Because it was having the highest priority. Now again I want to remove one more times. What will happen? You will remove which one? There are two elements having 3 priority, but one which came first will be having a, therefore a second time you are going to remove this one. In the third time you will remove this one. In the fourth time you will remove this one. And the last you will only obviously have to delete one. That means the priority will be deleted by first this one, then second this one, then third this one, then fourth this one, and fifth this one. This is the order of removal. Or you say order of dequeuing. Now this is how the actually it works. That whenever you are trying to remove an element, you remove by the priority and not by the positions. In the queue what we have read, the priority queues is having removal by priority and not by order. In a circular queue or a normal queue, you are going to delete by the place, by the positions. And this is only possible when you are having a priority associated with that. And this is one of the concepts what is being used when you are using a system with n number of terminals and with a one CPU. Now what happens is that when you are going to study in the next semester, we are going to do a lot of Linux over there. You find that what people will do, they will write a wrong code. For example, you write an infinite loop. What happens? The server which is going to execute your code will hang a bit. And what will happen? At that time, you cannot remove that. Now what I will do? I will log in as an admin and will try to remove your program from memory. Now one thing what you should know, because you are a computer learning students, we say the word process and we say a word program. There are two words which you use normally, program, and we use the word called process. As a computer engineering student, these are totally different words. Program is thing what you write on your terminals or you write on your copy anywhere. Process is that program which gets CPU. That means a program in execution is called a process. Now suppose there are a lot of people who are in a queue, and your program is taken by the CPU to run. It becomes a process. That means your program becomes a process. After some time, it again becomes a program. Program is dormant, process is active. Process is active state. Program is dormant state. That means you are writing a program on a terminal. It doesn't require CPU. You are saving it. It is saved on the hard disk. Doesn't require a CPU. But once you execute it, when you run it, that time the CPU is taken by your program. And at that moment, for let us take 1 second or 0.1 second or 0.0001 second, this program becomes a process and it comes out. Now suppose you have written an infinite loop. What will happen? Your program will become a process and will not come out. It will keep on running in the CPU. Now if you are using that CPU, obviously other people cannot use it because there is only one CPU in the machine. Now what I will do is that I will log in and remove a program forcefully from the queue. And for that, I have to log in as a higher priority user. Therefore, if you are running on such a system, on such a system, what happens is that here, if this is having a, suppose if you are a student, you are running a priority number 2, priority number 2, priority number 2, like this. I will log in from here with the priority number 1. I will log in from this terminal with the priority number 1. And even if a program is before mine program, I can always try to remove you. Now, this type of things are very common when you are using such type of things. But what happens in some cases, which we will try to just tell you in a just 5 minutes time, that sometimes what happens, if every time you find that higher priority numbers are coming, now what will happen? Your program will never get executed, isn't it? Because suppose you are assigned priority number 4. Now at 10 o'clock, your priority is at 4. Now after some time, another program enters with a priority 3. Obviously, your program will not execute. Again, after some time, once you were trying to get a CPU, another program enters with priority number 2, and you will be kept waiting in the queue. And a time will come where it will lead to a very important word which you are using over here, and this word is a word of operating system. We call the word as starvation. You are starved. That means you do not get the service. That means you are starved. Your process is starved, and this process is called starvation. Starvation is a scenario where you are in the queue to get CPU, but you are not getting. Why? Because every time it's a dynamic process. Every time some other process is coming with with a higher priority than you, and your process is not there. Now how it happens? Let us try to make like this. Suppose this is a very, very long queue, and here what happens is that you are going. Suppose this is a long queue like this. Now here, suppose you are user number 1, say user number 2, say user number 8, now user number 7, user number 5, now user number 20, and so on. And suppose this is you are at this place, priority number say 4. This priority number 3, this priority number 3, this priority number 2, this priority number 2, this priority number 4. Now obviously what will happen? At this moment you will find that it will first of all execute this one, 1. Then it will execute this one, 2. Then it will execute 3. But as and when it is going to execute over here, a new process comes. Let us say 15 number enters with 2. What will happen? Now this will execute. This will execute. Again, another process enters, say 18, with a priority number 1. This will execute. And suppose you are at this place over here, you are not getting any service. Because all the processes which are going to enter are having a higher priority than you. And you will be
increase of the time?
The time is okay. This enters suppose at 10 o'clock. This enters at 10 o'clock. This enters at 10 o'clock. 10 o'clock 1. This enters say at 10:1. This enters at 10:2. This enters at 10:1. And this enters say at 10:05. This enters maybe at 10:04. Now you had not got the CPU at 10:1. Then that means you have not got the CPU. Then these process came. Now what will happen? It will execute this one, then this one, and your time will not come because these are having a lower priority, higher priority, sorry. And you will be in the queue only, and you are not dequeued. Now this type of scenario, your process will starve.
Sir, so priority will increase due to time. After some time, that priority increase.
The OS has to take care of that. Now what will happen? The OS will have to take care. What will OS do? What operating system will do? It will try to find that what is the time when you entered it. For example, you entered at 10 o'clock, 1 minute past 10. Right now it is suppose 10:10. It knows that you have been waiting for 9 minutes. And OS what will do? It will try to decrease your priority from 4 to maybe 2. After again it checks after 5 minutes and find that you have not been processed. What will do? It is going to again increase the priority by 1. And now, once your priority is 1, you are sure to be executed. And therefore, the word is said as aging. It's called as aging. Once your process is aged, you are going to increase the priority. Now, in most of the case, why I took the lower value? Because in almost all scenarios, the lower value indicates a higher priority. 1 is having a higher priority than 2. 3 is having a higher priority than 4. Therefore, when I decrease the priority, it means I'm increasing the priority. And this is how the OS will do. Otherwise, what will happen? You might wait for hours and you will not be getting, because if you find every process will require the CPU, and a time will come where you will not be processed over there. And therefore, this is the scenario what is done by the operating system. Any OS which is going to use the concept of, say, multi-programming, and this concept you might be knowing is called a multi-programming. That means multiple programs are there in the system and the CPU is going to execute them one by one. Obviously, one thing you must be knowing, if you are having a single CPU in a machine, your machine can only execute one program at a time. It cannot execute 2 programs. Until your system contains 2 CPUs or 2 arithmetic units. It can contain 2 separate arithmetic units. Therefore, if systems are having a single CPU with a 1 arithmetic unit, it will only work for one of the processes at a time. But since it works very fast, do not know. It looks that everybody is getting your process is executing immediately. But right now, when I say 1 minute, 1 minute is totally useless in the computer, because computer will talk about microseconds. Take about microseconds. Therefore, the process might take 1 microsecond, 2 microseconds. Therefore, these minutes are just to give an indication that it is. But 1 minute process will not wait. It will wait for few microseconds. Therefore, this is the actual use of a priority queue. That priority queues are implemented in such a scenario where you are working on a client-server technology, or you are working on technology where you are having the therefore, whenever you are going to declare priority, you are going to use that. Now, the application of the areas of this is, I told you, I'll just repeat once here. The application areas over here. One, we call it CPU scheduling. CPU scheduling means you are going to schedule the CPU in the form of for processing all. Then you are also going to use in some of the graph algorithms. We'll discuss in chapter 5th unit. Some graph algorithms, some graph algorithm like shortest path algorithms. They use the concept of priority queues. Or for example, algorithm which is called as the spanning tree algorithms. They use the concept of priority queues. Okay. Now these are the examples of this. We will not, because these applications are used in chapter number 5, where you are going to use the algorithm like a Dicaster's algorithm. Now this is one of the very important algorithm. We'll study in the 4th unit, the Dicaster's algorithm. This is called the shortest path algorithm. To find the shortest path between any particular node to any particular node. And therefore, these are applications for this. Now, one thing what I will not say in details, but once you are going to implement a priority queue, we normally do not implement a priority queue as an array. Now we are going to use in the heap type of, we use a concept called as a heap. Then what we are going to do is that we are going to use it as a heap. Heap are basically, I'll just tell you in 1 minute what's a heap. A heap is a tree which will be something like this. Where the number at the top, or the parent is always bigger than the child. Now, if the parent is always bigger, or it could be smaller also, then its children. If I take the bigger one, I might write 100 over here, I might write 80 over here, 70 over here, 60, 45, 10, 8, I might write 60, I might write 68. Now you find that this diffraction is recursive. Now what is the meaning of recursive diffraction? It holds at all levels. 100 is bigger than 80, 70. 80 is bigger than 60, 45. 60 is bigger than 10 and 8. 70 is bigger than 60 and 8, 68. And at all levels, this will hold. Now, this type of tree is called as the heap tree. That means the parent is always bigger than or smaller than the child, and this differential is recursive, which means at all levels this has to be followed. And in this case, whenever you are going to insert the elements, you have to always insert from the left side. That means once you can insert, if you are inserting 8, you have to insert at the right of 60 and not to the left of 45, because you have to fill the from the left side. Suppose I want to insert any more element like this. I want to insert any more element. Suppose I want to insert 10. I have to insert 10 here. I have to insert, say, 10 here only. If I want to insert, say, 200, I have to insert 200 here only. But once I insert 200, the property is violated, because the property says that the parent must be always bigger than the child, which is not true at this place, which is not true over here, which is not true. Then I have to again rearrange it. Now this is not a heap. Why? Because this property is not followed. Parent is not bigger than the child. 45 is smaller than 200. Therefore, you have to again do. This is what we will do. We'll go to reheap it. We'll try to reheap it. This is called as heapify. We'll go to heapify it. Now this is another concept. But what I was trying to say, that when you are going to do that, heap is when you are trying to implement a priority queue, we are always trying to use as a heap and not as a array. Okay. Now, when I am going to use the binary heap means a heap which has maximum 2 children. That means the order of insertion will be order of 1. It's an order of 1. And insert will take order of log n times. Now, what will happen if I am taking a heap? The advantage is there. You might not understand it. Don't take it by that. We'll clear it after that. What happens in the heap is that insertion will take order of log n times. Okay, and to get the biggest number, so that means heap will take order of 1 time to insert. And to find the max, it will take order of 1 time to find max. To find max or to find min, you require only order of 1 time. And you know what is the meaning of order of 1? What is the meaning of order of 1? It means that the algorithm is constant time algorithm. Constant time algorithm means irrespective of the number of elements, the time taken will be constant. Because in here, you don't find any variables. Suppose I say order of say 100. What is the meaning of this sentence? If I say that the complexity of an algorithm is order of 100, what is the meaning? Anybody?
Constant time.
Correct. It's a constant time algorithm. That means this doesn't vary with n. Even if I have 1 million numbers, it will take order of 100. Or if I say if it is 1 billion numbers, it will take order of 100. But order of 100 we don't say normally. What we say is that it is order of 1 time. That is a constant time algorithms. And what happens when you are implementing a priority queue as a heap? To find the biggest number, you just require an order of 1 time. And to insert a number, you require an order of log n times. How? That we'll discuss. But let me just tell you one line. Why we say it will take order of 1 time? Because the max is at this position. What is the maximum number in this tree? Obviously, the top, the root. How much time you require to find? 1 time. If I ask where is the minimum number, you cannot do it over here. Minimum will take order of n times. Minimum कौन सा है? Obviously तुम सर्च करोगे सब जगह तो मिलेगा यहाँ है. कितना टाइम लगा? Out of n times लगा. Because तुमने सबको देखा, सारे numbers को देखे. Whereas to find the biggest, you took only the. What I will do is that if I want to find the minimum, I have to take the reverse tree. I will take a tree where the minimum number is at the top, and I can make a tree like this. Maybe I take 4, say 8, say 16, 20, 42, 90, 50, 23. No, this is the we call it, this is the min heap. The minimum number is at the top. How much time you try to find the minimum number? Order of 1 to get minimum. How much time to find the maximum number? बताओ.
N.
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 क्यों? Because I have to search all. I will first, because हमें search करना है, मान लो maximum. I will check maximum could be here also, here also. दोनों जगह हो सकता है. Therefore, in that case, for example, maximum यहाँ 90 है, एकदम नीचे पे है. But हो सकता था कि यहाँ पे अगर 230 होता, ये भी maximum होता. Heap अभी भी heap है. मान लो यहाँ पे होता तुम्हारा 160 और यहाँ होता 250, तो भी हीप होता. यहाँ अब मैक्सिमम यहाँ जाता है ना. If I cannot guarantee, मान लो यहाँ पे होता 425, ये हीप है ना. बिकॉज ये देखो पेरेंट जो है वो बड़ा है दोनों से, छोटा है, सॉरी. मैक्सिमम नंबर कौन होता? मैक्सिमम यहाँ होता. That means I have to search all. I have to search all. जैसे कि मान लो यहाँ पे होता तुम्हारा. Therefore, in that case, maximum कहाँ होगा? It will somewhere at the leaf, at the leaf nodes. It will be at a leaf. तो leaf मतलब क्या हुआ? Those nodes we do not have a child. Therefore, ये leaf है, ये leaf है, ये leaf node है, ये leaf node है. तुमको सारे लीफ को चेक करना होगा. देखो ऑब्वियसली तुमको सारे ब्रांच देखने पड़ेंगे. ये भी देखना होगा, ये भी देखना होगा. I have to take this one. ये भी देखना होगा, ये भी देखना होगा. That means you have to check all those branches. इसके मतलब क्या हुआ? जब सारे ब्रांच चेक करोगे or if you want to reach to 90, you have to reach via 8 and 20. That means सारे एलिमेंट चेक कर रहे हो, इसके मतलब ये ऑर्डर ऑफ n होगा. बट अगर हमें मैक्सिमम मालूम करना है तो ऑर्डर ऑफ n होगा. अगर हमें मैक्सिमम नहीं करके मिनिमम करना है तो ऑर्डर ऑफ 1 होगा. That means if I want to find the minimum, I require to make a min heap. If I want to get a maximum, I will try to make a maxi. And this is the whole concept. The priority queues are implemented as a heap rather than as an array. Though you can also use an array over there, but the time taken to delete will be not this one. If you want to find the best time, you cannot use a array to get this value. Correct? Any questions?
Sir,
Ah,
so wouldn't it be wrong if we write O of 8 instead of ONN for this specific min heap?
I'm not getting. Please repeat.
So wouldn't be it if wrong if we write O of 8 instead of O of n for this specific min heap?
No, see, order of
Because 8 elements are there, so we have to go search each and every element. So that's why
order of n के बदले क्या लिखे? Order of
8.
See, order of 8 is only for this particular problem.
Yes, sir. I am also concerned about this particular min heap only, not for the general case. So that's why I said O of 8.
Algorithms are only designed on a general case. अक्सर हम कहेंगे कि बताओ मैक्सिमम निकालने के लिए एक एरे में कितना टाइम चाहिए?
So that will be of O of n when the size is not given. But for this, I just said.
अगर एक ही एलिमेंट है तो ऑर्डर ऑफ 1 होगा.
Yes, sir.
दो एलिमेंट है तब भी ऑर्डर ऑफ 1 होगा. But when we talk about the algorithms, this number should always be dictated by irrespective of n. अगर तुमने किसी algorithm को order of 8 बताया, वो as good as algorithm of order of 1 है. यानी अगर हम इसको order of 1 भी कहेंगे ना, दोनों चीजें एक ही है. Order of 8 मतलब ये नहीं कि 8 टाइम्स लग रहा है. 8 टाइम में लग रहा है अगर n नहीं है, जिसे मान लो 1 मिलियन नंबर्स है,
Okay.
उसमें 8 टाइम लग रहा है. और एक 1 टाइम लग रहा है. दोनों में क्या फर्क है? कोई फर्क नहीं है. 1 मिलियन के सामने 1 भी और 8 इक्वल है. अगर 1 बिलियन नंबर है, 1 बिलियन, तो भी 8 और 1 में कोई फर्क थोड़ी है. इसके मतलब अलग बात है. यहाँ 8 नंबर के लिए यू माइट से ऑर्डर ऑफ 8, बट एज एंड व्हेन द ट्री विल बिकम बिगर, दिस विल नॉट बी करेक्ट. बट यहाँ पे n के मतलब हुआ कि जितना बड़ा ट्री है, जितने नोड्स है उतना.
Okay, sir.
Therefore, order of 10, 20, 100, 50, 200 are all constant time, and all are same as order of 1. Because अगर कहीं पे n नहीं आया तो ये constant time हो गया. जिसे मालूम हमने लिखा order of say log n. n आ गया. हमने लिखा order of say 2 to the power of n. n आ गया कहीं ना कहीं. तो जहां भी n आ गया ना, ये डिक्टेट करेगा n के वैल्यू से ये पूरा एल्गोरिथम चेंज हो जाएगा. अब देखो, अगर यहाँ पे n मान लो, n यहाँ पे मान लो 100 है, इसकी वैल्यू कितनी हुई? log n की वैल्यू अगर 2 तो तुम्हारा वैल्यू जो 9 होगी हार्डली, बिकॉज 100 n मतलब ये मतलब है इज इक्वल टू ऑलमोस्ट टू ऑफ 9, है ना? यानी ये हो गया, ये बेस 2 है, ये हो गया log ऑफ 2 to the power of 9, यानी हो गया 9. log 2 to 1 हो गया. बट ये कितना हो गया? ये हो गया, दिस विल बी ऑर्डर ऑफ से इट विल बी ऑर्डर ऑफ 2 to the power of 100. हाईली इम्पॉसिबल टू कैलकुलेट. तो n अगर पावर में चला जाता है ना, दिस बिकम्स वेरी डिफिकल्ट. दे आर कॉल्ड एक्सपोनेंशियल एल्गोरिथम्स व्हिच आर वेरी वेरी डिफिकल्ट, व्हिच इज हैविंग ए वेरी वेरी हाई कॉम्प्लेक्सिटी. मल्टीप्लिकेशन में इन्होंने आसान है, बट पावर में चला गया then it becomes impossible to calculate the complexity, and these algorithm becomes almost impossible to solve in a finite amount of time. ठीक है
Sir,
हाँ.
Sir, why does it called priority queue when it does not follow the basic concept of queue, first in first out?
No, it is following the basic concept of first in first out, but with the variant that first out is always based on priority.
So first out is
First
always
out, first out is based on priority, not on the basis of place. अगर तुम प्रायोरिटी से कोई चीज को निकाल रहे हो तो वो भी तो फर्स्ट आउट है ना. फर्स्ट इन तो हमेशा होता है, फर्स्ट इन के लिए कोई प्रॉब्लम नहीं है. फर्स्ट आउट बेस्ड ऑन ये नहीं है कि इंसर्शन जो होगा वो तो फर्स्ट इन ही होगा, जो आउट होगा वो प्रायोरिटी के बेस्ड आउट होगा.
सर, तो इसे हम प्रायोरिटी स्टैक भी तो कह सकते हैं.
हाँ, यू कैन से इट कुड बी लाइक दैट, बट ओनली थिंग इज दैट तुम बीच से एलिमेंट नहीं निकाल सकते. तुम्हारे कहने का बीच का मतलब ये हुआ कि एरे के बीच से. बट हमने कहा ना कि हमने उसको एरे की तरह इंप्लीमेंट नहीं करेंगे, वी विल ट्राई टू इंप्लीमेंट एज ए हीप. और जब हीप पे इंप्लीमेंट करेंगे तो मैक्सिमम हमेशा टॉप पे होगा. जैसे कि तुम्हारा जैसे यहाँ पे ये सब ने यहाँ पे किया था, ये तो यहाँ पे मुझे निकालने के लिए सर्चिंग नहीं करना होगा. What we'll do is that we'll remove 100 from there और लास्ट नंबर को उठा के यहाँ से इसको हम यहाँ कॉपी कर देंगे.
ओके सर.
तो क्या होगा, 100 बाहर आ गया, बट
Yes,
ये
sir.
200 जो है जो नया एलिमेंट देखो ये होगा, बट यहाँ 200 नहीं होगा. I told you अगर 200 होगा, सॉरी अगर 200 होगा तो इट इज नॉट ए प्रायोरिटी क्यू. अगर यहाँ 20 होता तो ये ठीक था.
सर, मैक्सिमम एलिमेंट एट द टॉप.
तो ठीक था, but 200 होगा तो it's not a heap. Therefore, what I said, priority queues are best to be implemented as a heap and not as an array. Array में कर सकते हो, but what is the problem? Now I just give you one. एक हम तुमसे क्वेश्चन पूछ लेते हैं, तुमको मालूम है क्या है. मान लो हमने एक array बनाया, तुमने कहा ना हमने कैसे बनाया, और हमने एलिमेंट डाला ऐसे A with priority 4, B with priority 2, C with priority 3, say D with priority 2, E with priority 1, and F with priority 1. ठीक है, ये हमारा ये है. मान लो at any point of time say T1, this is the scenario of the queue.
ओके
ठीक
सर.
है, अब तुमको इसमें से एक एलिमेंट को डीक्यू करना है. ये तुमको ये करना है.
सर, एज पर प्रायोरिटी एफ को डीक्यू करेंगे.
हाँ, एफ को नहीं करोगे. ई और एफ का सेम प्रायोरिटी है, बट ई पहले आया है तो डीक्यू करने में यू विल रिमूव ई हैज कम बिफोर दैट. हमने कहा था ना कि दो के प्रायोरिटी सेम होती है तो पहले हटाते हो जो पहले आया है.
यस सर.
हाउ मच टाइम विल टेक टू फाइंड ई?
ऑर्डर ऑफ 1.
तुम सर्च करोगे ऑर्डर 1 नहीं होगा, एरे में ऑर्डर 1 नहीं होगा. क्यों? तुम यहाँ देखोगे नहीं है, यहाँ खोजोगे प्रायोरिटी मिनिमम प्रायोरिटी तुमको मिलेगी यहाँ पे, कहीं तुमको सर्च करना पड़ेगा पूरे क्यू को.
सर, एन हो गया ना वो तो फिर.
तो ऑर्डर ऑफ एन हो गया ना, मतलब
Yes, sir.
रिमूवल टाइम पे तो लगा ऑर्डर ऑफ एन. कीप पे
Yes,
कितना
sir.
टाइम लगता है? ऑर्डर ऑफ 1. तो इसमें क्या है कि अगर तुम वहां तक तो रिमूव करते हो, इट्स ऑलवेज in order of n, because he could have been here, he could have been here, he could have been anywhere,
यस सर.
and therefore it's the order of n. एक एलिमेंट को हटाने के लिए ऑर्डर ऑफ n टाइम लगेगा. Whereas in that case it was only taking order of 1. और अगर तुम n टाइम्स एलिमेंट हटाओगे तो क्या होगा? It will be always in the terms of order of n log n. यानी अगर तुमने 1 एलिमेंट को हटाने में n टाइम लगा तो n एलिमेंट हटाने में कितना लगेगा? n into n स्क्वायर टाइम्स.
काफी ज्यादा कॉम्प्लेक्सिटी हो जाएगी.
हाँ, अब क्वेश्चन इससे पूछा है पीयूष ने, could deletion and insertion take place simultaneously if all of them have same priority? No. Priority same होने पे भी होगा, but insertion is always done one by one. Deletion is also done one by one. Therefore, मान लो ये एक किसी टाइम स्टैम्प T1 पे ये हमारा सिनेरियो है. टाइम स्टैम्प T2 पे क्या होगा? What will happen is that टाइम स्टैम्प T2 पे तुम्हारा ये हो सकता है क्यू तुम्हारा ये बदल जाएगा, बिकॉज अभी तुमने हटा दिया एलिमेंट हमारा ये बन गया, ये आ गया A4 B2 C3 D2 और F1, ये टाइम स्टैम्प T2 के। तुमने फिर F हटाया टाइम स्टैम्प T3 पे, ये बन गया तुम्हारा। टाइम स्टैम्प T4 पे क्या हटाओगे? B हटाओगे, बिकॉज B और D की प्रायोरिटी सेम है, बट B पहले आया था, therefore it is going to do that. Therefore this is the concept which is there. Now therefore it is a concept which is there. Therefore it is little tricky if you are going to implement practically. Therefore it is basically when you are going to do, therefore order of one जो हमने किया, जो whatever is written by Mayank, it is correct. It is an amortized analysis, but it is called an amortized analysis. अभी हम बताएंगे उसके बारे में नहीं, but आगे बताएंगे what is the meaning of amortized analysis. देखो ये बेसिकली जो हमने कहा ना ऑर्डर ऑफ वन टाइम जो बता रहे हैं, बेसिकली ये amortized analysis है ये, ठीक है। Therefore this is the concept, but this is the how you are going to work. What you said is perfectly correct कि ये जो है ये प्योर प्रायोरिटी क्यू वैसे नहीं चलता फीफो के तरह। यहाँ फीफो में फर्स्ट इन तो ठीक है, बट फर्स्ट ऑर्डर इज ऑन द प्रायोरिटी। अब इसी का एक वेरिएंट है, I'll discuss in the next class. It is called a multi-level queue, which will be something like this, and that is one of the things you will have a concept like this. ये चार या n नंबर ऑफ क्यूज जो है एक साथ होंगे like this. नो वेरी टिपिकल सिनेरियो। इसमें क्या है, तो चार क्यू है, हर क्यू की प्रायोरिटी जो है अपने हिसाब से एंटर होगी। अगर कोई वन नंबर, जैसे ये मान लो प्रायोरिटी नंबर 1 के लिए है, ये 2 के लिए है, ये 3 के लिए है, ये 4 के लिए है। कोई एलिमेंट अगर प्रायोरिटी 4 का आएगा तो इसमें जाएगा, इसमें कोई प्रायोरिटी नंबर 2 का है वो इसमें जाएगा, प्रायोरिटी नंबर 3 में है वो इसमें जाएगा। बट एक टाइम आएगा, अब ये तुम पूछोगे ये क्या है, ये बहुत एक टिपिकल लाइन हमने बनाई है, ये वाली हमने ये बनाया है ये।
हाँ सर, ये इंटरकनेक्टेड है।
ये क्यों है? बिकॉज एक मतलब प्रायोरिटी जब ये हो जाएगी तो उसको हम दूसरे क्यू मूव कर देंगे उसकी प्रायोरिटी को बढ़ाने के लिए। बेसिकली उसको उल्टा लिख देते हैं, इसको 4 लिख देते हैं, इसको 3, इसको 2, इसको 1। तो अगर मान लो कोई प्रोसेस बहुत देर 4 में रह गया तो उसको करेंगे क्या, हम वापस 3 में डाल देंगे। अगर 3 में बहुत देर रह गया तो हम 3 से निकाल के 2 में डाल देंगे। तो यानी हाईएस्ट प्रायोरिटी यहाँ पे, ये हाईएस्ट है। What I will do is that I will try to shift the element from the lower priority queues to the higher priority queues, and this is called multi-level queue. It's called a multi-level queue. A queue having multiple levels, where each queue is having one assigned priority. तो अगर सारे एक तरह के आ रहे हैं तो उनका हम क्यू में डालते रहेंगे। अगर देखेंगे उसका प्रोसेस स्टार्वेशन हो रहा है तो हम इसको यहाँ से यहाँ मूव करेंगे। बट स्टार्वेशन जो है वो हम लोग नहीं करते हैं, वो ओएस अपने आप करता है। बट ओएस इंप्लीमेंट करता है सीपीयू शेड्यूलिंग को। इसलिए हमने जो यहाँ तुम्हें लिखा था, ये आई रोट दिस वन ओवर हियर, वन ऑफ द एप्लीकेशंस थिंग जो हमने यहाँ लिखा था, ये बेसिकली जो लिखा था ना, वो सीपीयू शेड्यूलिंग जो है वो बेसिकली ओएस का पार्ट है। बट ओएस इंप्लीमेंट दिस डेटा स्ट्रक्चर ओवर देयर, इट इंप्लीमेंट्स अ प्रायोरिटी क्यू।
ओके सर। सर प्रायोरिटी क्यू और मल्टी लेवल क्यू?
मल्टी लेवल क्यू में भी होगा, बट विल जब रिमूवल होगा तो प्रायोरिटी क्यू होगी। दैट मींस जो एलिमेंट यहाँ से यहाँ जो मूव करेंगे वो यहाँ से यहाँ प्रायोरिटी के बेस पे मूव करेंगे। ये प्रायोरिटी नंबर 1 है, ये प्रायोरिटी 4 है, ये प्रायोरिटी 3 है, एंड सो ऑन। ये हाईएस्ट प्रायोरिटी है 1। Now these data structures are implemented by in any way you can do, but the basic concept is that you cannot move the element from middle until it is not having that priority. इसके मतलब अगर तुम्हारे पास क्यू है ऐसा, मान लो यहाँ A है, यहाँ B है, यहाँ C D like this है, तुम यहाँ से 20 से नहीं हटा सकते जब तक इसकी प्रायोरिटी जो है हाईएस्ट नहीं है. तुम ऐसा भी करते हो एवरी टाइम यू डू अरेंज द प्रायोरिटी. नो, दिस इज द थिंग. ठीक है.
Okay, sir. Yes, sir.
You started that one, yes.
Sir, today is 9 September.
अच्छा हाँ. Just that will come 64 out there. Now just for your I'll give you that how I am going to show it attendance.